thought it was already party time. Hey, thanks to be here for this last talk. I know it has been a long day, so I really appreciate it. I also really appreciate to be here in Croatia, especially since it's my second international conference in 1 year and a half. And to see you, and to be talking to you, and to see your faces, because I've done a lot of talks in this year and a half, but I was talking to my screen, which is not as great as talking to real people. So it's a bit sad that you are a bit far away. Anyway, I love interaction. If at any point you've got questions, I would love questions. Please don't ask questions. I won't mind. Probably I wouldn't be able to answer anyway, but I like questions, so send them. I'm Nicolas Frankel. For 2 decades, I've been a developer, mainly a Java developer. And since a couple of years, I've become a developer advocate. Most of all, I'm interested in a lot of different stuff. Right now, I'm learning Rust. A couple of years ago, I was learning Kubernetes, so I try to be creative in what I present. So the talk is zero downtime deployment. Why should we do zero downtime? That's the first question. Well, there are 2 answers to that. The first is that business wants it. I mean, every time you bring your app or your site down, that means that there is a direct loss of revenue if you're an e-commerce shop, or a direct impact on your image if you are not doing direct sales through your site. People are going to go to another site, and that's not really what we want. That's pretty straightforward. The second reason is that people in IT, at least old people like me, we are expecting sometimes to have static pages, to say, hey, the site is down, please come back in a few minutes. And that's nothing surprising. But people who don't work in IT, your parents, your brothers and sisters, they are used to Google, they are used to Facebook, they are used to Amazon, they are used to all those big sites that never, ever are down. So it creates a common expectation that apps are always up. And for them, it's their bread and butter. They don't even think, they do continuous deployment all the time. Whereas if you are a small shop, it's a bit harder. So the oldest trick in the book is BlueGreen Deployment. Who knows about BlueGreen Deployment? Yeah, a lot of people know about BlueGreen Deployment. For those who don't, that's quite easy. You have 2 environments. One that currently is production. By definition, it's the blue environment. You have your web server, you have your web application, you have the database. Everything runs on it. Meanwhile, you want to deploy a new version of your application. You deploy it on the green environment. It takes as much time as you need. People, they are just going on the blue environment. When you are ready, you say, hey, fire in the hole, and you hope for the best, and you direct every user on the green environment. Then, when it's done, you can store, backup, whatever on the blue environment, and then your production environment is not the green one, and you want to do the next deployment on the blue environment. And then it goes on and on and on and on. And Kubernetes comes here, and Kubernetes say, hey, folks, that's very easy. I have this rolling upgrade stuff. We have several nodes in the same deployment components. So here I have 3 nodes. You have pods with 1.0 version. We will do that in a rolling upgrade manner, and it works. And in general, talks about Kubernetes, they talk about that, and that's the end of the talk, and they pat themselves on the shoulder and say, yeah, that's great, we did it. And the problem is it's a bit more involved, unfortunately. And the issue is related to state. And the problem is that Kubernetes is really great at stateless workloads, and they don't talk about stateful workloads. Well, I have news for you. Most of our workloads are stateful, unfortunately. We don't like it. We dislike it. We would like everything to be linearly scalable, and that requires statelessness, but unfortunately, that's not the case. State is found in 2 different places. The first one is user sessions. Who here uses User sessions. Not so many people. What are the other one using? You don't do web stuff, right? Yeah, real engineers that do back-end stuff and they leave the sessions for the front-end engineers. Yeah, user sessions. Well, actually, that's a solved problem. In general, we do session replication, and we already do it for a long time, because in general, we don't deploy on a single node, but we deploy on multiple nodes, our apps, whether it's PHP, Java, or whatever. Then you have a load balancer in front, and you need to keep track of the node you send to, but if the node goes down, you still want user session to be replicated. So even though you have session affinity, you replicate your user sessions, and we do it for ages. Now we have also state in the database, and it's a bit more involved. Actually, when I presented to you BlueGreen Deployment, I told you, hey, we have like one blue database and one green database, which means that when we do the big switch, we need to migrate all the data from one database to the other. If you have 10 lines, 10 records, that's easy. If you have millions, not so much. So there is an alternative to BlueGreen Deployment. You have a single database. You don't migrate data. Problem solved. Actually, that's what I advertised before, and I thought it was the only solution. And I will present it to you, and then I will tell you how bad an idea that was. And perhaps in a couple of years, I will have another version of this talk, and the second option will also be a bad idea, because I will have come up with a better idea. But for now, let me tell you about the first option. So you keep the same database. It works very well until you need to migrate the schema. And sometimes the schema is not compatible. You have a breaking change. That's a problem. So now imagine I have a single database pod, and I do the same rolling upgrade with Kubernetes that I did before. And yes, I upgrade to version 2.0, the database to version 2.0, and the other parts, they break. Of course, they were not designed to cope with the version 2.0 of the schema, so that doesn't work like this. Okay, let's do better. Now we have a version 2 of the schema of the application that can deal with version 1.0 and version 2.0. Make sense to you? Yeah, I told you about interactivity. Folks, it's the last slot of the day. I want some interactivity. Does that make sense to you? Yeah, thanks. Okay, so that's fine. We will do the rolling upgrades, version 2.0 for the pods, and when we are ready, we upgrade the database pods. Problem solved. Problem solved until you need to do rollback. But you never, because you are very good engineers, and very good engineers never do rollback. Who here never do rollback? Come on, don't be shy. Yeah, sometimes it happens that we need to roll back, and in that case, we cannot roll back. If we roll back, it's not possible anymore. Not great. So how can we design a solution that fixes that? Here to design the solution, I need a concrete example. And here, I've worked in e-commerce a bit. Here is my usual example. I have an e-commerce model. It's a very simple one, as you can imagine. I have here. Does it work if I do this? Or here? Yes? Yes? No? Here? Yeah! Yes? You see, great. Here, I have my customer. Customer has multiple cart lines. Each cart line references a product. Well, pretty stupid example, but it works. And now comes the business. Notice that I'm a developer, and I use the image of an angry ape for the business. It's unrelated, for sure. But this time, the business has an interesting requirement. They noticed that people customers, well, not customers, users, put stuff in their carts and let it rot for ages. And they say, hey, this is an opportunity. Imagine we want, after a while, perhaps one day, perhaps 2 days, to send an email to the user to remind them that they have something left in their cart and perhaps propose them a discount, because in e-commerce, you always want to sell. The price is not that important. You want to sell at all costs. Sell, sell, sell. Makes sense. So I need to have a new concept, a new notion, the concept of a cart. So here I need to break my nice model, and between the customer and the cart line to insert a cart. It's a breaking change. So how do we handle this breaking change? Well, what we can do is we actually can split this huge breaking change into the series of small changes that are compatible side by side. So the first step is we create the cart table, and every time we do a change on the cart lines, we will replicate it to the cart. Still, the application still uses the old model as the source of truth. If we roll back, nothing happened. And here, I'm not prescriptive in how I replicate the changes. It can be code, it can be triggers, it can be anything. I don't care. Just say that I want that duplication occurs. The second step is now the application will use the new model as a source of truth, but again, I will replicate the changes to the old model. Again, if I roll back, because I replicated all the changes, I will get everything, and it's fine. Now comes the not so fun step. I will need to migrate data, because in step 1 and step 2, what I did is people were actually updating their carts. But when I started the migration, perhaps there were carts that were there and actually were not touched during the migration. And it might be a lot of them. So I need to migrate data. And again, 10 records, fine. Millions of records, not so fine. Then I do the cleanup. And that's what I advertise in my previous incarnation of this talk. And there are issues, actually. So every time you need to introduce a breaking change in the model, you need every time to decompose into those steps. You can only roll back a single baby step. Once you start a migration, you need to finish it. You cannot roll back 2 baby steps. So it saves you a bit of skin, but not your entire skin. It impacts everybody. It impacts, of course, the DBAs who are in charge of the model. It impacts the developer because they need to write the codes that say, okay, here I will need to cope with this model, and here I will need to cope with this model. And of course, it impacts ops that need to deploy it. And again, you will need to deploy data to migrate data anyway. That's not super great. So since we need to migrate data in all cases, why don't we use 2 databases and not have those issues from breaking changes? So now we need a way to move the data. And I don't want to go full-fledged in this talk. The demo is the more important one, but still, there is stuff that is called data streaming. Data streaming is actually, instead of batching, so taking chunks of data and moving them, data streaming is every time there is a change, you move the data. So you go from static to dynamic, you think about events. And then you have another enabler that is called change data capture, and the idea is that every time something happens on the database, something that changes the data, you capture it as an event. And then, through a streaming pipeline, you can transform it or do whatever you want and put it somewhere else. And now, we have just simplified our lives. Because now, we have, like devs, they don't care about the changes. They don't need to cope with multiple versions of the application. They just do their stuff, and it's done. And of course, it works with any deployment strategy that you can implement, such as canary release or whatever. So that is the definition of Wikipedia. I don't want to repeat it. I like to define change data capture as the opposite of event sourcing. With event sourcing, you store events, and by replaying the events, you actually get the current state. And of course, because the history of events can go a long, long way, you capture snapshots, so that is easier to recompute. With change data capture, you keep the same legacy system that you had before. So you won't be able to write those hype keywords on your resume, but for most companies, it's actually better because they don't need to change the way we work. Every time there is a change in your DB, you can capture it as an event. So how do I implement it? Here, I'm getting back to Kubernetes. So I have a deployment of three pods, and I have my Blue database, which is also implemented as a single pod. The next step, it looks really like BlueGreen Deployment. I set up my green database. It takes how long I need. Then, and that's the important part, I set up the streaming part. And that it reads every change from the Blue database, and it will move it to the green database. And here, you can do any transform. Actually, it's like ETL. It's smart ETL. So you can change from the old model to the new model. And again, it's continuous. It's continuously flowing. It's named stream for a reason. Now, I will start my deployment of the application pods. And that's the important part. Because in the previous version, in the previous step, here, every time a user, let's say on this pod, updated the database, the change was streamed to the new database. So when I deploy a new version of the pods, the data is up to date in the green database. And of course, at some point, all the pods will have migrated to the new version. And so you can keep your Blue database for auditing purpose. You can back it up just in case. And now the streaming, the forward job doesn't do anything meaningful because there is no more data changes here. Here I was too lazy, but of course, again, you need to plan for rollback. You should have a backwards pipeline as well to stream the opposite, just in case. Again, we are all good engineers. We never do rollback. But you should plan for that. And the best stuff that can happen is you will never use it. But still. But I was too lazy. And finally, it's done. And I'm working for Hazelcast, so I will present you how to do it with Hazelcast. But of course, again, there are other ways, other technologies to do that. Here, Hazelcast is a platform. We offer in-memory storage capabilities and in-memory streaming capabilities. Everything is distributed by essence. So on the streaming part, here you can read from a couple of sources. If a source, you don't have it, for example, you have a web service, you can hack your own. We have an API for that. Then you can do the transformation, whatever, and then you can write, again, in out-of-the-box targets or write your own. Hazelcast has 2 deployment options. If you are, who here is a Java developer? Quite a lot. So if you are a Java developer, it's very easy. It's just a jar. You set it in the class path. When you start your application, you start the nodes, and then there will be some auto-discovery magic. They will form a cluster. That's great. But soon you will notice, as when you start to rely on Hazelcast as a critical infrastructure component, you will notice that your application and Hazelcast node will compete for the memory because they run in the same JVM. So in general, after a while, you migrate to the client-server mode, so you have a dedicated cluster. We have Docker images, we have Helm charts, and then your application is actually just a client of the cluster. And it enables you to use stuff other than Java. So we have binding for Node.js, C#, C++, Python, and heaven forbid, even Go. I'm not a Go fan, but anyway. So here in the demo, I will use Hazelcast. Again, you don't need to do it, but, well, I'm employed by Hazelcast, so I will use it. Hazelcast for session replication, and I'm not using session replication directly. I'm using like Spring Boot session replication, Spring Session. And the other is I will use change data capture through a library called Debezium. So the idea is that this is my deployment. I will have like a JVM for Hazelcast, and I will run the job. Here inside, I will use Hazelcast, and inside, it will use Debezium. And Debezium is actually an abstraction layer. So you can use the Debezium API, and afterwards, you just need to change the connector, here the MySQL one, to Postgres, for example, and you can use for Postgres. So here, it's even better, because you can do the same, migrating for a blue database under MySQL to a green database under Postgres, if you really, really want. As long as you've got the connectors for Debezium, and there are already a lot. So I've talked a lot, and perhaps you are a bit bored. So now I will try not to make a fool of myself and try to show you a working demo. Yes, that's always the hardest part. I've already created an application, and now I've lost my mouse. It's here, it's here. Where is my mouse? Yes, no. So first, I need to find my mouse. I lost my mouse. And here, I suppose you don't see, you still see, yes, that's not great. So let's see how I can work with that. So first, I should show you something. Yes. And now perhaps, yes, I got my mouse back. So here you can understand why I'm not a designer, but a developer. It's not super great, but still it works. The session is not implemented through Spring Security or whatever. I just have a simple session. So here, the login is just, hey, you choose your user. It's perhaps a bit small. No? I will try to make it bigger. Here. So here, I have user Joe. Now user Joe has logged in. He has its cards, and I will put it a Yeti mug. And then user Jack will have 2 T-shirts. And then William 3, and Haver 4. 1, 2, 3, 4. So, because in the following, I want to show you data that is not touched, cards that user won't touch, and cards that user are touching. So that's the first thing. And here, K is the alias for kubectl, because again, I'm lazy. Get pods. And now, please don't let me down. Here, 3 pods, just as in my slides. 3 pods for the application, 1 pod for the blue database. So now I will deploy the green database, infrastructure cube green. Sorry, it's very hard not to do any stupid stuff. So green is being deployed. That's cool. Let's check K logs green dash F. So it seems to be ready. Yes, it seems to be ready. So that's fine. So now what I want to do is actually, I want to deploy the job. K. I've lost my mouse again. K. Apply F infrastructure cube forward. K get pods W. And then meanwhile, I can show you how it works. So here is the forward job. So I have a dedicated module for that. It's Java. Unfortunately, here you have no choice. But even if you are not a Java developer, I believe this is pretty understandable. I assume that even if you are not a Java developer, you know about the static main method. So here, it's not a framework, it's nothing. You just create like a standard main method, and then you will run the stuff. And the important bit here is the pipeline. How do you define the pipeline? Well, if you define the pipeline, you can actually read it in plain English. Like, I will read from the Blue environment, and I will add the ingestion stamps. And here, I'm using, perhaps it's a bit small, so here, let me make it bigger. So the change record is actually the stuff that I get from Debezium. It has a header and a value port, so I will just take the value port. The value port, I will explode it to a map, so I don't need to have any understanding. And afterwards, I will transform that into what I call call parameters. And call parameters, I will just extract the important bits, the bits that are important to me. Afterwards is the customer ID, the product ID, and the quantity. Actually, it's just the chord. And I write to the green environment. And again, reading from the blue environment, well, what I pressed something I shouldn't have pressed, yes. Reading from the blue environment is, you see, it's actually a primitive that comes from Hazelcast. You don't need to do anything. The only thing that you need to do is actually to do configuration. And here, most of the stuff is, where do I run? Do I run inside Kubernetes or not? And likewise, for the green environment is, hey, a lot of it is configuration, and the important part is insert cart line. This is my target. And my target is actually stupid stuff from 20 years ago. I'm calling a stored procedure. And that's super hype technology, so don't hire me if you want hype developers, but it works. Now, I probably think that it has started. I will open a new one here. K logs forward F. So here, we can see that actually the data that was already in the database before the job started has actually been managed and transformed and moved to the green database, because we see the stored procedure has been called. So now what I want to do is I want to click on the cards button to add new products with one user and hope that the user doesn't notice that their data has been migrated. So let's see how to do that. I will now K apply -f infrastructure cube application 2.yaml. Yes. And now, let's see, I will get back to Joe. And here you can see that's the node, and that's the version of the node. So, and here, that's the most interesting, dangerous, and boring part, because you see me clicking. Somebody wants to help me? Yeah, super interesting. I will just need to check at some point. So here you can see the logs. It's actually calling the stuff. Here, k get pods -w. And the one is, of course, it's always the last one. Now it's super fast. Yes, well, I missed it. But you understood the concept? I mean, I never lost any data. And now I need to continue my talk, otherwise I will be thrown out of the room because it tells me 0, 0. Yes. So I hoped I showed you a working demo. So takeaways from this talk. My latest takeaway from the previous version where I said, hey, option 1, use the single database, was don't do it. Here, I believe that with this approach, it's much more approachable, and that even if you're a small company, you can still do it. So it's possible, it's within your reach. For sessions, use session replication. You probably already have some in place, so just use the same. If you are using Spring Boot, use Spring Session, it's very cool. And for like the database, which is the hardest part, use change data capture and data streaming. So thanks for your attention. Here is my blog, here is my Twitter. More important, here is, I lost it again. No, here. Here is the code. So in case you want to do it at home, because you believe that I cheated you, well, you can try. And I will be very happy if you find some bug, because that's always nice. And if somehow I got you interested in Hazelcast, you can join our Slack channel or get some free training. And now, if you are not bored to death and you don't want to go to beer yet, perhaps you have questions, and I will be very happy to answer them. That's a bad sign. Oh, yeah, thanks. Sorry, can somebody bring a mic to the gentleman? Sorry.
Yeah, sorry. How does this exactly handle race conditions and such when trying to parse data change over insertions that are going into the original database?
But that there is no race condition, because actually either you are moving data from the application to the Blue database.
You know, in the initialization of the second database, you don't have the historical data from the first one. That has to be handled at some point.
Yes, but it's from database to database. So actually you have app to database, and then database to database. But the thing is, there is never a case where you have two versions of the app that go to the database. Either it's version 1 to the first database and it's replicated, and then when you deploy the new version, then the new version directly writes to the new database. So there is no race condition.
Yeah, but the initial initial data transfer is never it should happen simultaneously with the data change that's entering. If you just initialize the new database. So if you had only one database initialized with the data already in production, and then you start up the second database, it's empty.
Yes, then you do the streaming. And streaming, again, you set up the new database, you set up the streaming job, and you let it initialize as long as you want.
Okay, so the data change would happen after the initial insertion, or would it happen simultaneously?
But I'm sorry, I don't understand your question.
So you have 100,000 rows in the table already, and you're inserting at 1,000 rows at a second, I don't know,
but I'm not inserting
you're inserting everything into the first version, into the blue, and you're initializing the green one.
Okay.
You have to handle the 10,000 rows you had previously.
It's the same streaming job. I use the same streaming job to get the bulk that is already there, and at the same time, it handles the changes when they happen.
Okay, but if that's happening simultaneously, wouldn't there possibly occur a conflict?
Sorry, we must talk afterwards because...
Sorry, of course.
No, I don't understand how it can happen simultaneously.
Okay, well, we can potentially talk about this later.
Okay? No, but I'm serious.
Thanks for answering.
Other questions?
Just a quick one. I didn't notice.
Can you put it closer? Yeah, I'm old.
I'm hearing myself. It's bad. I didn't notice on the migration script. Actually, the streaming script you were executing. Where were the migrations? Really, migrations creating the new table. They're inside this script.
No. Okay, that's a good question.
I maybe missed it.
No, you didn't miss it. Actually, I didn't create the scripts in the migration. You could do it, but actually, I see no interest in that. So it's in my green database, YAML. I need to find it because so when I deploy the green database, I create a structure. In general, you don't let the developers create the schema. You have dedicated ops people or DBAs or whatever. So here, that's what I'm doing.
Yeah, I understand now. Yeah, everything fine.
More questions?
Well, it's beer o'clock time, so enjoy your evening. Thanks a lot, and well, you can find me if you have more questions.
Good job.